Hi dear children, welcome back to the chemistry session, periodic table. So hope you remember in the last session we have been discussing about how the classification based on a block, right? You have S block, P block, D block and F block. So we will come into that in detail a little bit later. So here as we are now at the present periodic table, we have already covered the history and now we are standing on the periodic table. Let us see some of the characteristics of the periodic table. Okay. So, again back to the periodic table, this is your periodic table and you know that there are 7 periods and 18 groups. So, you focus on this periodic table, this is exactly the same picture given in your NCERT. So, there all the group numbers are given. So, you are able to see this, right. You have 1, 2 and there are 3, 4, 5, 6 etc. and you have 18th group. So, dear children, did you ever notice there is one more such a type of group numbers given to the system? So, hope you are able to see here just below the number 1 you can see there is 1A, right. See there are 2A and this is 3A, 4A, 5A, 6A and 7 and you have 8. And you focus on this group 8, 8 is actually the group numbers given to the 3 groups. Okay. So, when you consider your 8th group, 9th group and 10th group all together is now considered in this Roman number 8. Okay. And after that when you consider you have 1B and you have 2B, 3, 2, 7B and then it is your 0. Okay. So, dear children, there is another set how to tell about the group numbers of a periodic table and the entire periodic table can be now also classified into 2 sets A and B. Okay. So, dear children, what are your A set? You have these are all your A set and after that you are having the B set. Okay. And that is the reason why I have written here. When you consider here there are 9 groups are marked from 0 to 8, right. So, here you have 1 to 8 and there is also another group 0. So, dear children, what are the total number? You will have 9 groups. Okay. So, that is another type of representation of group numbers. So, this A set is considered to be the major set and all the B set are assumed to be the subset. Okay. So, when you consider 1A and you consider 1B, so this B is the subset of A, that is how we consider the set B. Okay. So, that is about another representation. Mark this when you consider the 8th group. In this configuration, in this representation, there are actually 3 groups together. So, iron, cobalt, nickel, they are considered to be in the 8th group. Similarly, you have technetium, you have ruthenium, rhodium and palladium in the same group. So, this is actually known as transition triangle. So, you should note this transition triads, that is a better term that can be given. So, hope you remember Doberene's law of triads where he classified 3 elements into one set, right. So, similarly here as well in the transition series you are placing 3 elements, the successive 3 elements in one set and that is why this is known as transition triads. Okay. So, hope this is clear. We will be again discussing in detail about the properties. Okay. So, let us move into the next session, that is again the characteristics of the periodic table. So, here it is written every period starts with a member of alkali metals and ends with a member of noble gas except hydrogen. So, back to this periodic table, you know that when you consider the second period, it starts with lithium which is an alkali metal and it ends with neon which is a noble gas. But when you consider the first period, there is an exception because it starts with hydrogen, is not at all an alkali metal, right, because hydrogen is not a metal, then how can you place or how can you call this hydrogen as an alkali metal? So, except for the first period, rest of all periods are having the first element as the alkali metal and the ending element will be your 18th group element. Okay? Yes. So, the next point is very important. There is always a gradual change in the properties across a period. So, dear children, when you consider a period moving from left to right, there is a continuation or there is a gradual change observed in so many properties. So, we will see some of them. A good example would be valency. As we are aware of the term valency, we will start with this one. Okay? So, what is a valency? As you know, it is the capacity of an atom to give, accept or share electrons. Valency is the capacity of an atom to give, accept or share electrons in order to achieve stability or in order to achieve the octet state, right. So, that is the reason why when you consider oxygen, remember or memorize the position of the oxygen. So, oxygen is having 6 electrons in the valence shell, right. So, it requires 2 more electrons and then it will attain stability. So, in case of oxygen, as you need 2 more electrons to achieve octet, which is considered to be the stable configuration, the valency of oxygen was considered to be 2. So, this is an interesting factor because till now we have only considered valency as the number of electrons shared or accepted, right. So, here I am giving you the definition of valency with respect to 2 factors. So, dear children, when you consider valency with respect to oxygen, valency increases from 1 to 7 across a period if oxygen is taken as a standard. So, what do you mean by standard? So, here just consider here. So, when you consider here, let us say you have a third period element. Third period element, you consider the sodium. Hope you can read this. You have sodium. So, when you consider sodium oxide, how will you write it? So, you know the general formula how to write a configuration or a formula is like you have sodium and the valency or the outermost electron in sodium is 1. You have oxygen and oxygen valency, oxygen required 2 more electrons. So, its valency is 2. You will cross interchange and you can write this is Na2O. So, this is your sodium oxide, right. So, when you consider the next one beryllium oxide, how will you write it? Or you consider the magnesium oxide, it is MgO, right. You will write it as MgO. Why children? You have Mg2 plus and O2 minus. So, move forward, you have aluminium. How will you write aluminium oxide? So, you have aluminium oxide, as aluminium is having a valency of 3, oxygen with 2, you will just cross interchange and you get Al2O3, right. Consider the next element which is your silicon, I will write this is SiO2. Okay. So, consider your phosphorus, you have P2O5. What about sulfur? This is SO3. Consider chlorine, you have Cl2O7. Okay. So, SiO2 was actually written as Si2O4 because when you consider its valency, you have Si, silicon, and you have oxygen. So, what is the valency of silicon? It is 4 as it belongs to 14th group and valency of oxygen is 2. So, when you cross interchange, you are getting Si2O4 which is simplified as SiO2. So, similarly, we have done this one as well. Okay. SO3 is also written in like that manner only. So, this is your oxygen or oxides are taken. So, what do you mean by oxygen as standard? You are considering their combination with oxygen. So, what is the combination of sodium with oxygen? It is Na2O. You have MgO, Al2O3, SiO2, P2O5, SO3 and Cl2O7. So, you are able to see that sodium is having one valency here, magnesium with a valency 2, you have aluminum with a valency 3. When you consider silicon, it was actually Si2O4. So, silicon is having a valency of 4, this is 4. Consider this P2O5, right. So, just interchange, you get a valency of 5. Consider SO3, SO3 was basically it's your Si2, right, O6, because silicon it belonged to 16th group. So, it is Si2O6 which is written as SO3. So, dear children, you might be having a doubt that sulfur, it is sulfur dears, it is just sulfur. Okay. So, when you consider this, that is sulfur belonging to 16th group and you have oxygen which is also belonging to 16th group. So, I want to tell you one thing, consider these two combination, they belong to same group. So, one should act as a negative portion. Okay. As you know that there is always an interaction between positive and negative systems. You have to consider oxygen is more negative. So, that is the reason why we are assuming oxygen is gaining 2 electron. So, valency of oxygen here is 2. When you consider valency of sulfur, that is its group number itself. So, sulfur belong to 16th group, you have 6. Hope you do not get confused with the very old definition of valency. We are here taking oxygen as the standard. So, that is how you got S2O6 which is your SO3. So, sulfur here is having a valency of 6. In case of chlorine, the valency is 7. So, the valency keeps on increasing 1 to 7 when you move across a period. Okay. So, that is the first sentence indicates. Now, coming to the another standard of comparing the valencies, and that is valency with respect to hydrogen. Okay. So, you consider the second one with respect to hydrogen, and here yes, this was the definition that we have been following in the last several years. Okay. So, here valency increases from 1 to 4 and then decreases from 4 to 1. So, for example, when you consider lithium hydride, you can write its, this is your LiH, this is how you are writing lithium hydride. Okay. So, you consider beryllium hydride, the representation was BeH2. Consider boron hydride, you write it as BH3. And then carbon hydride, hydride means combination with hydrogen. You had CH4 which is your methane, with nitrogen you had NH3, with oxygen you have OH2 which is basically your H2O water. With fluorine you had FH which is actually written as HF. So, here as I have indicated all the hydrogen on the other side, I am strictly following that, but FH is actually written as HF, OH2 is written as H2O, that you know. So, when you consider in these hydrides, it is true that lithium is having 1, beryllium with 2, see number of hydrogen here, boron with 3, carbon with 4, nitrogen again having 3, oxygen as it have 2 hydrogen has 2 valency. So, here you have 1. So, with respect to hydrogen our definition was true, it increases from 1 to 4 up to 14th group, and after that it decreases from 4 to 1, and this is your halogens. Okay. So, that is about the valency. You can directly see the number of hydrogen or oxygen combined, and you can have the idea about the valency. Okay. So, valency was the first factor that we have discussed. to indicate the change in across the period, right. So, there are so many other factors as well which keeps on changing when you move from left to right across a period, and that thing is your metallic nature. This is very easy because let us again consider this periodic table, metallic nature, focus on the metallic nature. You consider a period, let us take third period where you have sodium, magnesium, aluminum, silicon, 2 argon. So, here you consider the extreme left side where you have sodium and magnesium, and sodium and magnesium, as you know, they are very good metals, right. So, go to the extreme right side, you have aluminum, which is also a metal. Silicon is a metalloid, and that is the reason why there is color change. Silicon is a metalloid or semi-metal. You have phosphorus, which is a non-metal, sulfur is a non-metal, chlorine is a non-metal, and argon is a non-metal. So, what is the trend you are observing in a periodic table? The trend is, when you consider the metallic character, there is always a gradual change in the metallic character. So, from left to right you are getting metals, and then metallic character decreases, you get semi-metals, and again decreases, you get non-metals. So, the change in the metallic character across a period that we are discussing is that left to right metallic character decreases and non-metallic character increases. Clear? Moving into the next concept, which is electropositive or electronegative character. So, dear children, just wait for the moment where we will discuss these two properties, electropositive and electronegative. Only just have an idea that metals are electropositive because metals will always lose electron and becomes positively charged. For example, you consider the sodium, right. If you take the sodium, you know that sodium is having a high tendency to lose electron, and you can have Na plus, right. Whereas, when you consider the halogen, fluorine or chlorine, they are having a tendency to gain electron and they become Cl minus. So, the ability to lose electron and then to become a positive charge is related to electropositive character, whereas the ability to gain an electron and become a negatively charged system is related to electronegative character, and both are opposite. Metals are electropositive and non-metals are generally electronegative. Okay. So, dear students, we will be discussing in detail about these two concepts later. So, the next one is also a new term, which is oxidizing and reducing nature. Yeah, I know that this is not at all a new term for you because we have already studied what an oxidizing agent and what a reducing agent is. So, the system which helps in oxidation is your oxidizing agent, and the other which helps in reduction is your reducing agent, right. So, this term about this oxidizing and reducing nature will be discussed in detail later. Okay. So, I am just listing some of the factors in order to tell you there is a change across a period. Okay. The fifth one is nature of oxide, which is very easy to understand. So, I am going to consider some of the oxides. Okay. I will take sodium oxide, that is your third period element. So, I will write the oxide sodium oxide, and it is your Na2O, that is your sodium oxide, right. Then you had magnesium oxide, you had aluminum oxide, right, P2O5 phosphorus pentoxide, you had SO3 sulfur trioxide, you had Cl2O7, yeah, this is your dichlorine, you have heptoxide. So, in all these oxides, what happens to their nature? So, I mean nature indicate whether they are acids or bases. Okay. So, if you consider this oxidizing natures, you know that sodium oxide is basically your NaOH, because in water it gives you hydroxide and that gives you NaOH, whereas SO3 in water gives you H2SO4. NaOH is a base, H2SO4 is an acid. So, what is the change in the oxide's nature? You understand the acidic character increases or the basic character decreases. So, that is about the nature of oxides. So, let us see some more characteristics about the periodic table. Okay. So, I have written typical elements. Generally, the second and third period elements are known as typical elements because they summarize the properties of a periodic table. For example, when you consider this periodic table, so again back to the periodic table. So, you consider here, and this is your second period, right? Lithium to neon, you have second period, and sodium to argon is your third period. So, generally when you consider the periodic properties, we do not consider 18th group. Can you suggest why? It is because they are actually least reactive, they are chemically inert, they will not react very easily, right. So, when you consider here, you consider the first group, you have lithium, sodium, potassium, rubidium, cesium and francium. So, this lithium and sodium, they are actually the starting elements. They will give you an idea about the properties of the group. For example, lithium and sodium are metals and you get an idea the first group elements are metallic in nature. Consider the second one, beryllium and magnesium. They are also having metallic characters, so that indicate the rest of the group members will also have similar properties. So, as the first two elements in these groups, that is second period element and third period elements, as they are showing properties of a group, they are considered to be typical elements. So, what is a typical element in a 13th group? It is boron and aluminum. What would be the typical element for the second group? It is beryllium and magnesium. Okay. So, this is about the typical elements. The next one, when you consider the typical elements among the second and the third period, you consider the third period elements which are also called as bridge elements. So, you consider here, I will take second A, okay, you remember this, right. So, you have 2A. Consider the third period element, that is your typical element. So, here you have only one third period typical element, which is magnesium. This magnesium is actually having similarities with calcium, strontium and barium, and also as this is 2A, now consider your 2B because that is the subset, right. So, after magnesium you are having 2A, the rest of members here, and also you have 2B here. So, this indicate magnesium is having properties similar to the rest of the members in 2A and also similar to the members in 2B, because A and B, they are actually subsets to each other. So, this magnesium is now called as the bridge element, which connects the rest of the members between 1A and 2A, or here this 2A and 2B. Okay. So, this is idea about the bridge element. So, back to the slide. After typical element, I have written here bridge element. So, the typical elements of the third period is your bridge element. So, when you consider the second group, that is your magnesium, which is acting as a bridge element. Why? Because when you consider the magnesium, this is your magnesium. So, this magnesium is having similarity to calcium, strontium and barium, and also with zinc, cadmium and mercury. So, magnesium is a bridge element. Okay. So, it is very easy to identify a bridge element. All the bridge elements are the third period elements. Okay. And next thing is about the diagonal relationship. A very interesting factor that we are observing in the periodic table is an interconnection in properties for the diagonally existing elements. For example, you consider lithium, beryllium, boron, carbon, and what is the very next element? You have sodium, magnesium, aluminium, and you have silicon. It is always seen that lithium is also having similarity with the diagonally existing element, which is magnesium. Beryllium has got another connection with aluminium, and boron is having a connection with silicon. So, only the three elements lithium, beryllium and boron also shows similarities with the diagonally existing element, which is known as diagonal relationship. Okay, so this is a little idea about the diagonal relationship. Why and how this happened will be discussed in detail in your coming chapters. So, this is about some of the examples about the change across the period and group, and hope you understood and hope you enjoyed this video. So, guys, we will see in the next session with the next property. Thank you.